All right, so we're going to do some things algebraically today, and this is really, it's your notes slash your homework, so I'm going to do a couple in your notes just to remind you of some things, and then you're going to do the rest on your own. What I wanted to remind you of is that as far as when you're solving algebraically and you're factoring, remember, in order to factor, you must have 0 on one side. Have 0 on one side. Meaning, if I see somebody, and I'll see this throughout the year, and I'm just like, oh, for the love. If I have a question maybe like this, equals 12, believe it or not, this is what I see on some papers. They go, oh, factoring out an x, that's cool. That's x minus 1 equals 12, so x is either 12 or x minus 1 equals 12, so I get x is 13. And I'm like, oh, dear heavens, no. If you are factoring, you have to have 0 over here. So don't, if you do this, you're going to get a lot of red on your paper and a very sad teacher. Okay? If you're factoring, you must have 0 to one side. So you're going to factor. Now, the ways that you factor, like number 1, you all have a different method. You have got to be able to factor that. I am not going to teach factoring. You've been doing it since Algebra 1. Questions 2 and 3, I hope those stand out to you. When you see 4 terms, what is a popular factoring thing is, of course, grouping. So remember, you have grouping. I'm just going to use some thoughts. Questions 5 and 6, let's think about when you're solving rational functions, think of what you're going to do to solve that. Well, undo the rational function, if you will. Meaning, let's see, I'll start number 6. I'm not even going to start it. Well, I'll start number 5. It's easier. If I start number 5, I'm like, okay, let's multiply through by x plus 2. So if I multiply through by x plus 2, well, it gets rid of the fraction on the left, so I have x squared minus 16. Now what do I have on the right? Well, 0 times anything is still 0. So I'm just solving that, which should make sense. In a sense, that should make sense to you, because if I look at the original problem, in order for a fraction to be 0, the numerator would have to be 0. So that would make sense. Now, when you do that on number 6 and get rid of that denominator, you are not going to get 0 on one side. You're going to get something else. You have to move to one side, factor, and go from there. So that's my hint on that one. As far as 7 and 8, when you're solving and you have x to an exponent, I'll go through number 7 because it's actually the harder of the two. And here's the deal. You're going to isolate the exponent. So x to the 2/3 is equal to 16. Now what are you going to do? You're going to raise to the reciprocal power. Now why is that? Because what you want is x equals. So in other words, you want x to the first. So that's why you raise to the reciprocal power, because power to a power you multiply. If it's negative, you're going to be raising to a negative. You have to multiply and get 1. Now here's why I'm saying number 7 is more difficult, because this is the answer that I would get. And people would say, well, the square root of 16 is 4. 4, remember with fractional powers, if you're in my class, I said flower power, where you have the root on the bottom and you have the power or the flower on top. So the square root of 16 is 4, and 4 to the 3rd is 64, and that's the answer that I get, which is a correct answer, but it's not all the correct answers. So here's the deal. When you're doing this solve, if you raise, the power that you raise to has an even power right here. Friends, you have to remember a plus or minus. Now let me be very clear, because There are two answers that work. Negative 64 would also work. Let me be very clear. From the first week of school, or for the rest of the year, if I say, what is the square root of 25? The square root of 25 is only 5. Because square roots, think of the parent function that you have, looks like this. When you put in 25, you don't get plus and minus 5, or it wouldn't be a function. You just get 5. When you are solving, which is really x to the 1/2, if I was solving and did x squared equals 25, and you're listing all the values that make that true, that's kind of what I said. Well, if you raise to the 1/2, if that bottom power is even, you have to remember to put in the plus and minus. The square root of 25 is 5, but you have to put in the plus and minus. So I just wanted to point that out. If the power that you're raising to has an odd root, then you do not need to put that. I said even. I wrote even power. I meant even root there. If the power you're raising to, I just noticed that as I was talking, I might have said root. If what you're raising to, when you choose to raise it to a power, if this is an even root, you have to put the plus or minus. Okay. Last thing I'm going to do with you is I am going to do, which one do I want to do? I'm going to do a rational function. I'm deciding on which one I want to do with you. Oh, this one looks pretty good. I'll do number 10. Okay, so here's the deal. So let's think of the rational rules. How did you find domain? Okay, and I'm going to write the rules out so you have them. Domain is you look at the original and you think denominator cannot be 0. So anything that is in the denominator, you have to throw out. So x can't be 0, 3, and 2. For wholes, that's where you need to factor. Okay? You need to factor, and I'm going to factor this thing. If I took out a 2x, would you agree that that would be x squared minus 1? So I'm going to go ahead and factor into x plus 1 and x minus 1. So I would have this. Correct? Okay. A whole is when you have a factor that it's in both in the top and bottom. So it makes both numerator and denominator equal to 0. When you do this canceling, then that is going to be a whole. So you have a whole at 0 because the factor that I canceled was x. So what makes x 0 is 0. If you ended up canceling at x minus 4 and have an x minus 4, then the whole would be at 4 comma something. Now, how do you get that something? How do you get that y value? You plug this, whatever you got for your x value, you plug it into the remainder of the equation. So in the remainder of the equation, I have a 2. I have a 0 plus 1 is 1. 0 minus 1 is negative 1. I have a 0 minus 3 and times negative 2. So what does that end up being? What is that? Negative 2 over negative 6? Nope. Negative 2 over positive 6, which is a negative 1/3. That's how you get the x value or the y value of the whole. Now, how do you get the VAs? VA makes only the bottom. Okay, friends, equal to 0. If something is a whole, it is not a VA and it is not a x-intercept. Once you cancel, that's your whole. So just look at the remainder. So the VAs are what's left in the denominator. X equals 2 and X equals 3. Notice I want you to write it as X equals. I want you to write it as an equation. Now I'm going to skip the EBA for just a minute. The x-intercepts are what makes the top 0. Makes only the top equal to 0. So again, I've already done my canceling for the wholes, and I would get, I'm going to put, just for the ease of space, I'm going to put plus and minus 1 comma 0. Now the y-intercept, you're going to plug in 0 for x. However, the second I wrote the whole has a hole at 0, then I know I'm not going to have a y-intercept, because a y-intercept is a closed dot. So if I have a hole at 0 or a VA at 0, I'm not going to have a y-intercept, but that's how you get it. Now remember the EBA? That stands for in behavior asymptote. That's either a horizontal asymptote or a slant. So remember that was your 3-case thing. And if you were in my class, again, we remember Bobo Botten, eats DC. This is for HA. Bobo stands for bigger on bottom, 0. Okay, bigger on bottom, 0. Bigger on top, none. So this is bigger on bottom. I'll write it out. The higher power is on the bottom. You're going to have an HA of y equals 0. If the bigger is on top, then you don't, N stands for no HA, which means if they differ by 1, you have a slant or an oblique asymptote, and you have to do long division to figure out what that is. If the exponents are the same, then you divide coefficients. And you're going to get y equals some number as an HA. So in our example, I could have told that from the beginning. I can look here or here. It doesn't matter. I'll get the same thing. I'm just going to go from the original. The highest power on top is x cubed. If I multiply out this denominator, I would get x cubed as well. So I have this scenario in this problem. The exponents are the same. So I divide the coefficients. 2 over 1 is 2. So I would get that. Now let me do my problem. Well, I'm going to have VAs. I'll just do marks here so we can kind of count those. Okay, so what do I got? I have a hole at 0, negative 1/3, so I'll just put a little, I've got the definite over there. I have a VA at 2 and a VA at 3, so I'm going to have something real skinny in there. I have an x-intercept at 1 and negative 1. And I've got a HA at 2. Now, if you remember, we talked about if you have 2 vertical asymptotes, you're going to have 3 things that you need to draw. You always have one more section than you need, one more piece than the number of vertical asymptotes. So let's just start. You can always plot points. I try to avoid plotting points as much as possible because it just takes time. But if you're stuck, you plot points. You plug in numbers into the original or into this one and get a value, and you can get more points. But I do it by kind of thoughts, especially if you have an HA other than 0. You can probably figure out a lot of the sections on your own, because if you think about it, let me erase this so it's not in my way. This right-hand most section, I have 2 options. This, because it's going to follow the asymptotes, or this. Well, which one does it have to be? Well, it has to be on top because I don't have an x-intercept out there. So I cannot cross the x-axis, so I know it has to be like this. In the middle section, because remember I got something in between there, can I cross the x-axis? Well, no, So I either have up here, now you can cross, let me be very clear, you can cross an HA. So you actually could have something like this, and that would be legal, or it would be down here. Now if you go, well, which one is it? Well, then plug in a number. There's also VA rules that I taught, and I like those. If you remember what those are, you could figure it out without plotting a point. But let me just show you plotting a point so that you can get it if you're unsure. When I say plot a point, I don't actually get the number. I just have to figure out, I know I can't cross the x-axis, so I just need to figure out positive or negative. So I'm putting in a number like 2.5. If I put a number like 2.5, of course 2 is positive, 2.5 plus 1 is positive, 2.5 minus 1 is positive, 2.5 minus 3 is negative, and 2.5 minus 2 is positive. Well, if I have an odd number of negatives, it's overall going to be negative, which means it's going to be this bottom one. So I know it's going to be like that. And then the last section you probably can figure out on your own, because if it has to go through these dots, it has to, and these zeros are to the first power, so they're not going to bounce. So they're going to go through those zeros. So if I'm coming up here, it's going to have to go through. Yes, I can cross an HA. So it's going to do that. It's going to go through that, and then it's going to level off at 2, and there is my graph. So hopefully that is a good reminder of rational functions. All right, so do the rest of those that we have not done for homework, okay?